Okay, welcome back everybody. We are going to learn about how to write a polynomial function with given zeros, okay? And these are given zeros, okay? So we want to write a polynomial function that will have the zero of -2 and 2 and -5. So what that means is when we plug in our variable, when we substitute in -2 into our function, we want to get 0 back. And when I substitute 2, I want to get 0 back. And when I plug in -5, I want to get 0 back, okay? So let's see what this would look like, all right? The basic idea goes back to the factor theorem, okay? So really, cannot emphasize how important this theorem is enough. The factor theorem, okay? A is a zero of a polynomial function if and only if, so this is going both ways, all right? A is a zero of a polynomial function. Let me put this A in quotation marks so you guys know that we're not talking about A is a zero, okay? We're talking about A, the number A, okay? Is a zero of a polynomial function if and only if x minus a is a factor of the polynomial. So we know what our zeros have to be. And so if you really understand the factor theorem, you'll see that if these are zeros of the function, then these have something to do with the factors of the polynomial that we got them from, okay? So let's work it out, okay? So we know if a is a zero, so what's our first zero? -2. So if -2 is a zero, then that means x minus what? X minus a. And what's a in this case? One of our zeros, right? A is a zero if and only if x minus a is a factor. So since we want that to be a zero, we're going to make it a factor, because that's the only way that they can both be true, okay? So here we go. We're going to put -2 in for a. All right? We'll simplify that later. Now, let's multiply our next thing, okay? We're going to multiply by x. Well, minus how much? Well, minus a, right? And what's a in this case? It's +2. So we have x minus 2. And then in this case, we have the last one is going to be x minus a again. But what's our a? It's -5, so I have to do x minus -5. And that's why the parentheses are important, because they help you keep track of when you're subtracting a negative, and you know that that really turns into a positive, right? So that's what we're going to do in this first step. We're going to change this x minus 2 to x plus 2. We're going to change this to, well, nothing. It stays the same, right? And this one we're going to change to x plus 5. And this is pretty close to a polynomial function, right? This is a polynomial. If we multiply it out, it's going to look exactly like a polynomial in standard form, right? So hopefully you guys are ready for that. Well, hopefully you see the difference of squares right here. So x plus 2 times x minus 2, that's just x squared minus 4, right? And so really I got x squared minus 4 times x plus 5. And what's that make for us? We're going to get x cubed plus 5x squared, and then minus 4x, and then last we're going to get the minus 4 times the 5, and we're going to get minus 20. Alright, so I was doing FOIL, I forgot to draw all my arrows and everything, but that's x times x, and then x times 5 makes 5x squared. Then you got the 4 times the -4 times the x makes -4x and minus 20, okay? So this polynomial function, all right, you might not know just by looking at it. If I told you, oh, if you look at that thing, what do you get when you plug in 2? You probably wouldn't tell just by looking at it without calculating all the values that you're going to get 0. But when you look at the factor form of that polynomial, it's obvious that, yeah, 2 is going to give me 0, because 2 minus 2 is 0, and 0 multiplied by anything is 0, okay? So that's the way this works. All you have to do is make sure you subtract from our variable in the binomial, subtract the zeros that you need, all right? So let's practice that one more time. So now we have 4 zeros, 4 of them, okay? So let's just lay out the problem the way it's going to be. Since there's 4 zeros, we're going to have at least 4 factors. We're going to need 4 factors. So we're going to have x something, x with something, x with something, and then x with something, okay? So really, what makes this really fast is if you learn to just change the sign of all the zeros, then you do it the fastest way possible, okay? So change the sign. Since a is a 0, all right, is the same thing as x minus a is a factor, right? Well, I know if 3 is a 0, then x minus 3 is a factor. This is the factor theorem, right? So I'm going to change this 3 to a minus 3. And I know that I'm supposed to subtract negative 2, but that really means I'm just supposed to change the sign. So let's change the negative 2 to a positive. Let's change the negative 5 to a positive, and change the negative 4 to a positive, okay? I'm not going to bother multiplying this out right now, okay? But rest assured that if you do multiply it out, you'll have a polynomial function, all right, after you combine all the like terms, that has the given zeros that we wanted, okay? So that's pretty much, I really want you guys to practice this part right here of just labeling out your factors and everything like that. It's really important, okay? Really important step before we start multiplying out and getting lost in that part, okay? This is the most important part of the problem. So here we go. Let's try this one, all right? Let's break it down. You guys ready? Go ahead, press pause and try to do this one on your own, all right? And we're back. Let's see what happens. So we're going to write this as, not so big, we're going to write this as x. Put how many factors? Well, we have 4 zeros. So if it has 4 zeros, that means it has to have 4 factors. So now, like I said, you change the sign of everything. So we change the positive 2 to a minus 2. We change that 4 to a minus 4. We change the 0, well, to a minus 0, but that doesn't really do anything, does it? And then we change it to a minus 4/3. All right? So the only thing that we could simplify more is x minus 0. What's x minus 0? It's just x, right? So I could write this as x times x minus 2 times x minus 4 times x minus 4/3. Alright, and that's the way that this problem goes. Let's try one more and see if you guys get the hang of it, alright? So, number 12, alright? I'm going to wait for you guys to work this problem out, okay? Go ahead and press pause and try it. And let's go, alright? So, we're going to write our factors, okay? There's 4 zeros, so we're going to have 4 factors, right? So we have our 4 parentheses. This is a 2, so like I said, we're going to change the sign to a negative. So we change 2 to negative 2, x minus 2. Now we're going to change this to a positive 2, so this is going to be x plus 2. This is going to be changing the sign to a minus 5, and then change the sign to a positive. So you have x plus 4, okay? Well, this is the way to go through and do these problems, all right? Like I said on that first problem, the way that I really went through and multiplied out, you guys have had plenty of practice multiplying out polynomials, so we're not going to congest this video by putting too many different skills in here, okay? I want you guys to practice writing a polynomial function, all right, with the given zeros, all right? You have plenty of ways to do that. You can find more examples on the internet, or you could just make yourself a random list of numbers. Just think of them, you know, 5, 3, 4. All right, what's this going to be? It's going to be x minus 5 times x minus 3 times x minus 4. All right, so whatever. Just practice doing it. Make sure that you get the hang of it, okay? You have to change the sign every time. So watch the video again if you're a little lost here. But good luck studying, guys, all right?